Okay, so in this video we are going to traverse an array, and there are two things we are going to learn. Is first is how you can write the algorithm to traverse an array, and second is how you can find the complexity of traversing an array. So first thing is an array and you want to traverse it. What does it mean? Traverse means you are going to access each element of the array and you are going to print all these elements. So let's say we are having an array, the name of the array is A and the size of the array is 10. Means it is fixed, only 10 elements are allowed and all these elements are there. Okay, so in case you want to access any element from the array, you need indices, right? So these are the indices. So if I talk about the first element, the index number is 0, and if I'm saying I want to access the element at 0 index, I will get this value, right? So similarly for first index I will get the second value. So what I'm trying to say is, if I use any variable I is equal to 0 to get this value, so it is going to point to the first element, and similarly if I write I is equal to 1, I'm going to access the second element, and if I write I is equal to 9, it is going to access the last element. So actually I'm accessing the random element, right? So what if I want to access all these values one by one, and I just want to print it? This is what we call the traverse. So to do that, if you have seen this, what I said before, I'm accessing the first element and the last element. So the first element is actually the lower bound of the array, right? And the last element of the array is the upper bound, ub, right? So here in this case, the lower bound is the 0 and the upper bound is the 9, right? So in case if I know the lower bound and the upper bound of an array, I can simply traverse this, because I will get to know the number of elements in an array. How? There is a formula to access that: upper bound minus lower bound plus 1. So here the upper bound is 9, so 9, then minus lower bound is 0, then 0, then simply add 1, which is equal to 10. So if you see, the size is actually the 10. So by using the lower bound and upper bound, I'm actually guessing the actual size of the array, right? In case if you have been given these two values, you can simply get to know what is the size of the array, and this is what we want to traverse an array, right? Okay, so uh, let's say if you have been given some different index number, the first element of the array is at the index number 1, means the lower bound is 1. In that case, the upper bound is equal to 10. These two values are given and you have to find out how many numbers of elements are there in the array. So you can simply use this formula and put these values. Upper bound is 10 minus 1 plus lower bound, oh, sorry, yeah, no, 10 is the upper bound minus lower bound plus 1, sorry for that. Okay, so the value is still 10, right? So if you start the lower bound from 1 and upper bound is 10, the array is still the same. So in general we use the index number 0, but it completely depends on you, or sometimes it depends on the language, whether they are going to use the 0 as the index number or not, or say the first element is stored at the 0th index. Okay, so you must remember this formula. Whatever is the language, you just simply know what is the formula to get to know the number of elements in an array, right? So here I'm going to start how we can write an algorithm to traverse an array. Okay, first you need to initialize the index. Index means you must know the lower bound, right? For that we are going to write the variable. If you are going to program in any language, you just need a variable. Let's say we are using I, and we will put lower bound equal to the that variable, which is I here. So let's say we are having an example here. Array name is A and lower bound given is 0 and upper bound is 9, which is actually defining the size. Okay, not actually the size. Let's say we are using size is the name of the variable here. We will use that name later. Okay, so first we initialize the index I is equal to lower bound, and then we will put a condition while I is less than equal to upper bound. Means if the upper bound is defining the last element, then we want to iterate it. Means we want this condition, let's say I is 0, and it will increment to the 1 2 3 4 up to any number, and this condition is going to check till the size of the, or you can say it is going to reach to the last element. So for that we are using the while condition, and we are going to repeat the third and fourth part, or you can say the steps 3 and 4 for this condition. Means whenever this condition is true, 3 and 4 is going to be executed. So what is going to happen in the programming? I said I is the variable, and we are going to write less than equal to. Size is the name of the variable which used to store this number, right? So if this one number is 9 and I put it here, what it is going to do is a particular uh, statements, here we are using the step 3 and step 4 will be executed for this condition. Means if the I is 0 and then here is 9, I is 0 which is less than equal to 9, yes, then execute 3 and 4, and then what do we need is keep on executing these this particular condition for 3 and 4. Let me write the 3 and 4 first. Print value at the index I. Means at this index number, if you remember the previous instruction I wrote, print value at the index number I. If it is 0, the value at the index number 0 will be printed, and then in programming we are going to write the print is the name of the array and I is the actually we are accessing the index, right? Then increment the index I is equal to I plus 1. Now we are incrementing the value by 1. Okay, and finally let me read this whole program now again. I was 0, and if we put 0 here and size is 9, so which is upper bound, I'm using the variable here. So this condition will be checked, and for each time it is true, the step 3 and step 4 is going to be executed. Let's say it was 0 and the value is 9, this condition is true, and what is going to happen? The print value, the value will be printed from A0 for the first element, and then it will simply increment I by 1. So if the value is incremented, now the value is 1 and the size is still 9. For 1 also the I value is changed here 1, and then it will print the value. If you remember, I was just accessing the random values. Now we are accessing all the values one by one by using this condition, right? And after this condition is true, this print command will be executed, and then number will be incremented one by one, right? So this will go until the value is 9, right? And after the I is equal to 10, this will false and it will simply exit, right? So in any programming language you are going to write this algorithm, or you can use this algorithm to write any or you can write a program to traverse an array in any programming language, right? Okay, so if I see this example, the first element is as 0, means the LB is, or you can say the lower bound is 0 here and the upper bound is 9, and if I want to access this, whatever I wrote into the algorithm, this can be satisfied by using the for loop, because for loop is giving us all the things we want to traverse an array. Let me show you. First we initialized value, right, to the lower bound, which is 0. So this is the part in the for loop which let you initialize the value. Second is used for the condition. Here I wrote the condition I less than size minus 1. See, there are two ways. In the previous slide I wrote I less than equal to size, right? So if the size is 9 here, right, so it is going to check when until the value is 9. But here I'm not using the equal sign, which means the value will go till 10. But the size minus 1 means if I write 9, size is this one, right? So size is 10, minus 1 is 9. So now I'm using this part not equal. So that's why I just subtracted one value. I hope you understand this part. Okay. So next part is simply the increment, and all these things are provided by the for loop. That's why we are using the for loop for traversing an array. And then simply write the print statement for each uh, condition true here, the particular statement will be executed and then it will be incremented. Let me clear this part. Whenever you are going to use the for loop, if you know the for loop, there are three things. First, you just simply initialize, and this condition is keep on executing again and again, and this is going to be executed again. But for this particular condition, it will go to here to print this statement and then go back here to increment, and then increment for that it is going to check the condition again and going to print again. This is how the for loop works. Okay, so now comes to the complexity, right? So initialize the index, which is going to take the constant time because it's simple instruction which is going to run one time, right? So next is print the value at the index I is again going to take the constant time, which is going to be printed once, and again the increment is going to take one time. Okay, but this part, if you see, while this condition is true, it is going to repeat third and fourth part. Means these are taking 1 plus 1 is 2 values, and this is going to be executed till the size, or you can say the upper bound. Let's say the upper bound is some number n. For the worst case we are going to take, the value can be anything. In our example we just took the array of 10 elements, but the size can be anything, right? The number is n. So for n times this part is going to be executed, and it is going to execute these two statements also. So 1 plus 1 is 2, and if we see this part, the complexity of this part is 2n, because 2 is from here and it is going to be true for the n numbers. So that's why we are using n here, and if we write in the form of big O, so it can be written as n, because we take the highest rate of growth, if you remember the previous lectures. So we can say the complexity of traversing an array is big O of n. Okay.